Chapter 1.9.2 Resource Quotas. Here is a short summary about the article. Resource quotas ensure fair resource allocation among multiple users or teams sharing a cluster. Administrators set usage limits per namespace to prevent resource monopolization. If requests breach quotas, they fail with HTTP 403 errors. Certain scopes help refine quota applications, with specific constraints for advanced scenarios like priority classes and cross-namespace affinities. Resource quotas manage and limit resource use in Kubernetes by setting constraints within namespaces. They protect against overuse, ensuring resources are fairly distributed among teams. Advanced controls cater to compute resources, object counts, and special cases. Violations in setting or respecting quotas result in automatic rejection of resource creation or updates. Resource quotas in Kubernetes mitigate resource contention among namespace groups. Defining specific limits on CPU, memory, storage, and object count, they guarantee resource fairness. They evaluate namespace usage and block excessive requests with HTTP 403 errors unless limits are properly defined. Scopes further regulate specific resource types or priority classes. Okay, that was the short summary. Let's have a deeper look into the contents. Resource quotas. Resource quotas are crucial for managing cluster resources among multiple users or teams to ensure fair and controlled access. Administrators define these constraints through resource quota objects to cap resource consumption per namespace. Each team's workspace, defined by a namespace, can be assigned specific resource limits, ensuring equitable distribution of clusters comprising a fixed number of nodes. The quota system monitors resource usage in each namespace, ensuring teams do not exceed specified limits. If a user attempts to exceed their quota, the admission request is denied with a 403 forbidden status. The system requires users to set requests or limits on resources like CPU and memory. The Limit Ranger admission controller can assist by setting defaults for pods lacking resource specifications. When a namespace-specific resource quota is enabled for CPU or memory, all new pod submissions within that namespace must specify limits or requests for those resources. The system demands resource specifications to prevent the rejection of pod submissions. Without such requirements, inefficiencies or failures in resource allocation could arise, hindering operational effectiveness. Resource quota policies can define resource allocations such as allowing Team A more resources than Team B, with reserve quotas for unused portions. Unique namespace policies may permit unlimited resources or apply specific boundaries. Contention can occur if total allocation exceeds the cluster's limits, handled on a first-come basis without affecting current resource usage. Enabling resource quota. Resource quota is typically enabled by default in many Kubernetes distributions through the API server's Enable Admission Plugins = flag. Resource quotas are enforced within specific namespaces when a corresponding resource quota is present, helping manage resource allocation effectively. Compute resource quota. In Release 1.10, Kubernetes added quota support for extended resources, preventing overcommit and only allowing quota items with the requests prefix. For example, to limit the GPU resource, nvidia.com/GPU in a namespace, set requests.nvidia.com for. This feature primarily targets managing and limiting compute resource requests in a given namespace. Storage resource quota. You can set storage limits in a namespace and differentiate quotas based on storage classes like gold or bronze. In Release 1.8, ephemeral storage quota support is introduced, affecting pod eviction due to log storage. Check logging architecture for more. Object count quota. The Kubernetes API allows setting resource quotas to manage the total count of a specific resource type using the syntax count resource, group for non-core, and count, resource for core group resources. Examples of resources under object count quota include persistent volume claims, services, secrets, config maps, replication controllers, deployments apps, replica sets apps, stateful sets apps, jobs batch, and cron jobs batch. Such quotas apply to Kubernetes API server resources and custom resources with a custom resource definition, but not to APIs added through API aggregation, unless enforced by the extension API server. Using countWidgets.example.com, for instance, could establish a count quota on the widgets custom resource in the example.com API group. Quotas help prevent resource exhaustion issues, such as restricting secrets, which could stall server operations if overused, or limiting jobs to control cron jobs from overwhelming namespaces, causing denial of service. For specific resources like pods, quotas restrict the maximum number of active, non-terminal pods within a namespace to prevent depletion of pod IPs. Setting these restrictions helps manage resource allocation and cluster stability. For comprehensive examples, refer to the guide on viewing and setting quotas. Quota scopes. Quota and scope filtering. In Kubernetes, a quota is used to manage and measure the consumption of resources by defining associated scopes. Each quota is limited to resources that align with its defined scopes, and any misalignment results in a validation error. Notable scopes include best effort, terminating, not terminating, and not best effort, each with specific resource tracking capabilities like pods, CPU, memory, and more. Certain combinations are disallowed to prevent contradictions, such as terminating with not terminating and best effort with not best effort. Operator usage in scope selectors. Scope selectors employ operators like in, not in, exists, and does not exist to facilitate resource management within quotas. When defining scope selectors, specific rules govern the combinations of operators and their value fields, affecting how resources are tracked. For instance, exists requires that no values field is specified, whereas in and not in require at least one. Appropriate application of these conditions ensures effective and conflict-free resource allocation. Priority class-based resource quoting. Kubernetes allows users to manage system resource consumption based on pod priorities using scope selectors. Quotas are matched to particular priorities, ensuring specific resources are tracked, including pods, CPU, memory, and ephemeral storage. Different quotas exist for varying priority levels: low, medium, high. Operators can create and manage these using YAML files, ensuring resource usage is appropriate for the priority level, reflected through changes in the used stats for monitored quotas. Cross-namespace pod affinity quotas. With Kubernetes v1.24, managing pod affinity across namespaces becomes possible through the cross-namespace pod affinity scope. This feature ensures that pods with affinity terms do not disrupt scheduling by improperly influencing which namespaces have executable affinity commands. Resource quotas with specific configurations, including constraints on affinity terms, can prevent cross-namespace affinity misconfigurations, helping maintain balance and control over system resources. Code example. The code defines a scope selector in a resource quota object that matches pods at a specific priority class. In this case, it selects pods with a priority class of middle for tracking and consumption within the quota. This means that the quota will only measure usage for pods with the priority class middle. The code defines 3 resource quota objects: pods high, pods medium, and pods low, each with specific hard resource limits for CPU, memory, and pods. These resource quota objects are scoped based on the priority class value, with pods high being limited to pods with a high priority, pods medium limited to medium priority, and pods low limited to low priority. Each resource quota object restricts resource usage for pods within the specified priority class. This code uses the kubectl command to create a quota object based on the YAML file specified in the file path /quota.yml. It allows for the creation of a resource quota that tracks and limits resource usage for pods based on specific priorities. The code creates 3 resource quotas, named pods high, pods medium, and pods low, each for a specific priority class of pods in a Kubernetes cluster. These quotas restrict the usage of system resources for pods based on their priority level, ensuring that resources are allocated efficiently within the cluster. This setup allows for better control and management of resource consumption by different priority classes of pods. This code command is used to display details about the resource quota in Kubernetes, such as the usage and limits for specific resources like pods, CPU, memory, etc. It provides information on how much of the allocated quota has been used and how much is still available. The code defines 3 resource quota objects named pods high, pods low, and pods medium within the default namespace. Each quota specifies the maximum limits hard for CPU, memory, and pods that can be utilized, as well as the current usage used of these resources, with all quotas showing no resource usage. This code defines a pod named high priority with a container running an Ubuntu image. The container has resource requests and limits set for memory and CPU usage. Additionally, the pod is assigned a priority class named high to control its consumption of system resources based on its priority level. This command uses kubectl to create a pod with a high priority level by applying the YAML configuration file named highprioritypod.yml. Once executed, the pod will be created with the specified high priority level in the Kubernetes cluster. This command is used to display detailed information about the resource quotas in the Kubernetes cluster. It provides an overview of the usage and limits set for the resources defined in the quotas. The output includes information on the namespaces, scopes, and specific resources being tracked by each quota. The code shows 3 quota objects in the default namespace. Pods high has 1 out of a hard limit of 10 pods used, with 500 meters out of 1K CPU and 10 GI out of 200 GI memory used. Pods low and pods medium have not used any resources allocated to them, with pods low having a hard limit of 5 pods and pods medium having a hard limit of 10 pods for their respective resources. This code defines a resource quota object named Disable Cross Namespace Affinity in the foo-ns namespace with a hard limit of 0 pods. It specifies that the quota is scoped for the cross namespace pod affinity scope and will only be applied if the scope exists. This code defines an admission configuration object for the resource quota plugin in a Kubernetes API server configuration. It specifies that the limited resource is pods and that it should match the cross namespace pod affinity scope with the exists operator. This configuration restricts the usage of cross namespace pod affinity terms to only namespaces that have a resource quota object with the cross namespace pod affinity scope and a hard limit greater than or equal to the number of pods using those fields. Requests compared to limits. When managing compute resources, containers can request and limit values for CPU and memory. Quotas can be set to either resource requests or limits. A request quota requires container applications to make explicit resource requests for CPU or memory. Similarly, a limit quota mandates that containers specify explicit limits for the consumption of CPU or memory resources. Viewing and setting quotas. kubectl allows managing resource quotas, including object count quotas for all standard namespaced resources using the syntax count lat resource. Group. Code example. This code creates a new namespace called MySpace using the kubectl command. Namespaces are used to logically divide and isolate resources within a Kubernetes cluster. This command allows for specific resource management and usage restrictions within the MySpace namespace. This code creates a resource quota named compute resources that sets limits on CPU, memory, and NVIDIA GPU resources for the Kubernetes cluster. The quota specifies a request of 1 CPU, 1 GI memory, a limit of 2 CPUs, 2 GI memory, and a request of 4 NVIDIA GPUs. The quota is defined in a YAML file named computeresources.yam. This command creates quotas for compute resources specified in the computeresources.yaml file in the namespace called MySpace. kubectl is being used to create the quotas, which will control the resource usage of objects within that namespace. The code creates a resource quota named object counts with specific limits for various standard namespaced resources, such as config maps, persistent volume claims, pods, replication controllers, secrets, services, and services load balancers. Each resource has a specified maximum count that it can have within the namespace. This code creates quotas for object counts defined in the objectcounts.yaml file within the specified namespace, MySpace. It sets limits on the number of objects that can be created for each standard namespaced resource. This code retrieves the quotas for the namespace MySpace using kubectl. It lists the quotas that have been set for creating, updating, and viewing resources in that specific namespace. This code snippet shows two different quotas that have been defined: compute resources and object counts. The age of these quotas is specified in seconds, indicating how long they have been active. The quotas seem to be related to managing resources and object counts within the Kubernetes namespace. The code is using the kubectl describe command to provide details about the quota named compute resources in the namespace MySpace. This command will display information such as the total count of standard namespaced resources that are being limited by this quota. The code shows the quota limits for various compute resources in the namespace MySpace. The used and hard limits for CPU, memory, and GPUs are displayed, with limitations on the maximum amount that can be utilized. The namespace MySpace has a limit of 2 CPUs, 2 GB of memory, and 4 GPUs available for use in this case. This code is using kubectl to describe a quota named object counts in the namespace called MySpace. It will display information about the object count quota for all standard namespaced resources in that namespace. The code snippet is showing the current usage of resources in the MySpace namespace, as well as the quotas set for each resource. The secrets resource has 1 out of the allowed 10 objects created, while the rest of the resources have not reached the quota limits yet. This information can be helpful in monitoring resource usage and capacity planning. This code creates a new namespace called MySpace using the kubectl command. Namespaces are a way to organize and partition Kubernetes resources within a cluster. The kubectl create namespace command creates a new namespace with the specified name. This code creates a quota named test as defined in the namespace MySpace. The quota restricts the maximum number of deployments to 2, replica sets to 4, pods to 3, and secrets to 4 within the specified namespace. This ensures that only a limited number of each resource type can be created within the namespace. This code creates a deployment named nginx, using the nginx image with 2 replicas in the MySpace namespace. The deployment will manage the specified number of replicas of the nginx container in the specified namespace. This code is using the kubectl describe command to display information about the quotas set for the MySpace namespace. The output will provide details about the constraints and limits imposed on resource usage within that namespace. This code snippet shows the current resource usage for various objects in the MySpace namespace. There are 1 deployment out of a maximum of 2, 2 pods out of a maximum of 3, 1 replica set out of a maximum of 4, and 1 secret out of a maximum of 4. The count, resource, group syntax indicates the object count quota for each standard namespaced resource. Quota and cluster capacity. Resource quotas define limits on resource consumption independently of cluster capacity. They are set in absolute terms and aren't affected by the addition of nodes, but complex policies can allocate resources proportionally among teams and allow flexible growth within set limits. Policies using resource quotas can be enhanced with controllers that adjust quotas based on consumption signals, avoiding resource exhaustion. Quotas divide total cluster resources but not node-specific allocations, allowing namespaces to coexist on the same node. Limit priority class consumption by default. To control usage of certain high-priority classes within a Kubernetes cluster, operators can implement a mechanism where pods at a specific priority, such as cluster services, are only permitted in a namespace that possesses a corresponding quota object. This restricts access to high-priority classes across namespaces by default. To enforce this, the kube API-server flag must be set to include a specific configuration file, and a resource quota object should be established in the kube system namespace. Pods without priority class name or with a specified priority other than cluster services can be created freely, but those with cluster services must be created in the kube system and pass the quota check. Otherwise, such requests are rejected if they fall outside this namespace.